Welcome back. Well, let's talk about the impact of electric vehicles on the electric system. First, it's important to understand the different types of vehicle chargers that are out there because each of them place a different demand on a distribution electric system. You have the level 1 charger, which is the 120 volt plug-in, the charger that you get when you purchase an electric vehicle that's included in the purchase of the vehicle. You take your vehicle home, put this in the garage, plug it into the wall, and you charge your vehicle generally at night. Probably takes 6 to 7 to 8 hours to fully charge your vehicle. So the user of this type of charger in a residence is paying the general residential electric rate to charge their vehicles. Then you have the level 2 charger, which requires a separate dedicated line, separate installation by an electrician to put in. It's about twice as fast as the level 1 charger, 240 volts. It's installed at home or it can be installed in public places. Many charging stations use these types of chargers as well. And even though it's quicker at home, if you don't have a time of use rate for the residents, the user of the level 2 charger is charging their electric vehicle at the general residential electric rate for your rate tariff. Then you have the level 3 charger, which is a rapid charger. It can charge a car in an hour, charges semi-trucks, things like that. It's a DC power, direct current power, and you find these on highways or commercial areas where electric charging stations have been built. When you look at the system infrastructure needs for electric vehicle charging and the impact that it will have on the grid and on distribution systems, here's a study that assumed 1.1 million EVs in service by 2030, and their estimate is that the representative utility will need to make cumulative transmission and distribution investments of $2.8 billion for an estimated grid capacity upgrade cost of $2,600 per electric vehicle. You notice this study was in 2019 and the usage has really ramped up since then. So it kind of sped up this forecast just a bit. And another study said that many experts believe that a complete transition to electric vehicles will require as much as 1.25 trillion kilowatt hours of electricity each year. And that's enough electricity to power 117 average residential homes for 1 year. So you remember the last lesson when we talked about the dramatic increase in the need for electricity over the next 10, 15 years and beyond. One of the big drivers, again, is electric vehicles. The other big driver is electrification of everything that we do, and that will also impact it. But electric vehicles by far will drive the need for spend and building of infrastructure of the grid and distribution systems. Now, there was a study done in El Paso, Texas, of the example of 10,000 plug-in electric vehicles on their system, and they did it by level of chargers, as you see over here. Now, the whole level 1 chargers, you see folks are using those mainly at night to charge their vehicles. And the idea is that this system peak here, the higher this is, the higher the cost of electricity and the higher resources of generation that are needed to meet all of the needs of the electric system. So you see the impact of these other chargers. Here we have level 2 chargers at work. People charging their cars when they go to work. Here we have public level 2 chargers out there in the community. If the community had built charging stations and had that type of program, so people driving throughout the community can have the opportunity to charge their vehicles, and that would be during the day when people are most active. So a peak period in many electric utilities is probably about noon to 6 o'clock, 8 o'clock, depending on the weather and the amount of air conditioning load. So the idea again is to drive this peak down and drive people towards charging their vehicles in these off-peak periods. And we're going to show you how rates can be used to get that effect. So the load curve, charging customers at traditional residential rates, electric vehicles will drive the system peak. If there's no incentive for me to charge my vehicle at night, then I'll do it whenever I'd like. If I need it during the day, I'll do it. I probably will anyway, but maybe it's more convenient for me to do it during the day. So I will use maybe a public charging station or a work charging station to do that, because the rate doesn't really incentivize my behavior to do anything different. Now, with a time of use rate, the peak impact may be mitigated as more EV users charge during the off-peak period. You want to charge or move that charging to the off-peak periods, early morning, late at night, drive that system peak down. That is the goal. So again, the study found that 16 to 15 billion in distribution system upgrades are needed for charging to build that infrastructure in distribution systems across the country. And the point we want to drive home here is that you need to study your distribution system to identify additional equipment and other infrastructure. Perhaps you're going to build electric vehicle charging stations under the umbrella of the utility. Perhaps your city would like early adoption of electric vehicles, so they'll drive that through programs, charging stations, and so on. You need to investigate grant programs that are out there to help fund this infrastructure building, as there's much of that money is out there right now that can help you mitigate the cost for the infrastructure upgrades. So let's talk next about a sample of electric vehicle charging rates, and we'll show you what some other utilities are doing to help drive that charging behavior to the off-peak hours. See you back here in a minute.